extend a warm welcome to the resource person of today's talk, Shri Shrikant Seelin, President, Metlink Associates, Daly City, San Francisco. I heartily welcome you, sir. I would also like to welcome our beloved principal, Dr. Basavrachel, to this talk. I welcome you, sir. I would also like to welcome Dr. Bhagyashri SR, Dean Research, ATME CE, who is also the convener of today's technical talk. I welcome you, ma'am. I would like to extend a warm welcome to all deans and HODs of various departments to this event. I also extend a warm welcome to all the staff members and students who are present here. Thank you. Thank you, Likita. Now I call Ms. Kirtana C. from second year EC department to introduce our resource person, Shri Shrikant Seelin, President, Metlink Associates, Daly City, San Francisco.
Good afternoon, everyone. I feel privileged to extend my warm welcome to one and all present here on this present day. Successful people are not gifted, they just work hard, then succeed on purpose. Now it's my pleasure to welcome the Honorable Personality, Shrikant N. Seelin, sir. A former president of the Institute of Industrial Engineers, Silicon Valley chapter, Shrikant N. Seelin, mechanical engineer, is a co-inventor of IR imaging process and equipment. He was also a co-founder of Seelin Technology Test Labs. He has provided wide-ranging thermal analytical test services for compliance, testing to JDEC, EIA, and SEMI standards for over 2 decades. For numerous startups and pioneers in the chip industry, he was a host member to NASSCOM in 1994, IT industry launch from Mumbai. He was also Standards Board member at SEMI International, former director at the Indo-American Chamber of Commerce at California at San Francisco. He is also a member of the San Francisco Bangalore Sister City Organization and a volunteer judge at Synopsys SCBS EFA Science Affairs. He was a former consultant to Government of Ontario, Canada, among a high-tech international group. He was a delegate and ambassador at the World Wind Energy Conference held in 2008. He was the chair of the subcommittee on renewable energy at the Indian Technology Congress 2014 at Bangalore. He was a runner-up award at the Cleantech Global Competition 2014 in San Francisco for a hybrid vertical axis solar wind power generator on behalf of Solar Motion Corporation. He was the original designer and builder of advanced high-tech assembly line for NMR scanners. He was also a former advisor to Federation of Karnataka Chamber of Commerce, India. He has been listed in the international Who's Who of professionals and Who's Who in California. He has also spoken at various international engineering and business conferences, including IEEE, SEMICON, etc., in the United States of America, Canada, and India since over a decade. He also enjoys instrumental music, traveling abroad, and freelance photography as his hobby. Thank you.
Thank you, Kirtana. Now we would request Shri Shrikant Seelin sir to share his views and educate the gathering. Over to you, sir.
Young friends of ATME, it is my pleasure indeed to see a wonderful campus. I had no idea how it was. I've been traveling around Nepal, Annapurna last week. I was climbing up there, over 7,000 feet. Quite an experience. Traveling around parts of the US and Mysore, by the way, is my also very, very favorite old hometown. As a child, I used to literally my first day in school was a small, tiny little school in Nazarbad area in Mysore. So Mysore is a special place in my heart. Wonderful to see you all and see such a growth in the education field, and you certainly have a pretty significant challenge in front of you. And Mysore is also quite well known in the educational field, even despite the fact that I've had a chance to travel around the world and see other institutions. I'm quite proud to say, of course, you should all be proud to know Mysore definitely has a place. If one gets the time to read British history records, the Kingdom of Mysore was recognized in 1930 as by far and beyond the best administrated kingdom on the entire earth, entire planet. This is by the British journals, it is on record. Have a major, we are fortunate to have a very good background and opportunity to study. Not many people in India have the opportunity you guys have. So because of my limited time, I'll go directly into the subject. It is my privilege and opportunity, it as a dream from when I was a student also, to go and work in Silicon Valley in the high tech. And somehow I've been privileged, lucky and fortunate to have done that. After doing my BE Mechanical at Bangalore University, I worked briefly at MICO, and then went to Clarkson University, New York, did my master's in business, and did some exciting projects. I was just telling your dean. Interfacing with Government of Canada, Government of New York about the 1980 Winter Olympics. That was the MBA class project for us. Now we come more into the subject here. While you're waiting for that, what I want to highlight to you is India is embarking on, it's on the verge of going into a vast 100,000 crore plus investment in the semiconductor industry. This is no joke. Needs a lot of people. Very serious people, absolutely talented, totally dedicated. This is one field that is most significant challenges in manufacturing. Like any good restaurant, if you want to take an international quality, if you look at any of the Tata restaurants, their food is top notch. Even in San Francisco, I can tell you firsthand, people from abroad come to the Tata Hotel to have lunch because of the caliber of their cuisine and quality of the food. So that implies that the cooks know what they are doing on a daily basis. Every day is a challenge. Likewise, in the world of semiconductor manufacturing, as opposed to any other field, in my opinion, and I have had the opportunity to work in paper, machine tools, automotive, several industries. Arguably, in my opinion, nothing comes close to the challenge in electronics chip manufacturing, which is desperately needed in India. We have a spectacular record of failure in the last 3 decades. This is why it is so important that youngsters like you who now face the challenge, you will be on the front line soon, and your dedication and success will make or break the next level of growth in the electronics field. vast difference between software and hardware. Historically, India has led the world, I guess, in many ways through the NASSCOM, which incidentally I was one of the coordinators for the first NASSCOM delegation in the United States in Silicon Valley in 1994, which launched the entire IT industry in India, representing the Indo-American Chamber of Commerce in San Francisco. Apart from software, hardware is so critical. All the software you can think of, it doesn't make any difference if it's not based on something. If you have a computer, yes, you can use your software, but without the computer, what is the use of your software? And if you're let's say you're driving an EV, and you want to see how good, what is the level of the battery, can you go 5 miles, 50 miles, 100 miles, 200 miles? Something on the panel, instrument panel, the instrument panel will indicate whether you have 5 miles left worth of power charge or 2 miles, 5 miles, 500 miles, right? Yes, those are all software, fine. But without the chip inside, there is no use of the software. You'll be doing nothing, right? So it's so critical to understand hardware. So just to give you the starting slide will just give you a little bit of a insight, like a bird's eye view, how big the field is. We're talking tens of thousands of crores in each and every sector. So what I want to basically highlight is the fact that the world of semiconductor chips, its application is very wide. So you can have from automotive electronics to aerospace to defense, missiles, rockets, and very mundane agricultural timing and temperature control for cold storages. So you have quite a wide spectrum. Oh, okay, fine, okay, got it. So I would like you to look at this center here. I'd like to compare this to what Sir M. Visvesvaraya observed in the 1940s. Without electricity and power, okay. Without electricity and power, a country cannot grow. There is no energy for anything. So I would like to draw that analogy today. The wafer fab is the heart of your electronics. It can power an entire economy, entire country. It's got so many different applications, from aerospace to $6,500 million. These are worth of applications that can actually be built. In automobile field, from 100 to 3.5 billion. Broadly speaking, just to give you an idea, agricultural business from 100 to 2.5 billion. I'll go into more detail later. From transportation, 100 to 2.5 billion. Medical electronics from 100 to 2.5 billion. That is the application side, that is the market side, the market is so big. Now, you see the yellow circle here, this refers to medium scale industries. Medium scale industries, I guess I'm loosely defining as between 10 to 100 million dollar turnover. And the green circle here is small scale industries between 1 to 10 million dollar turnover. India needs all of them. They're totally blank. People may take exception. How come ISRO has done a world record this, that? We've got Chandigarh complex, we've got the other small, but by and large, if let's say you needed 100 chips, we are not even producing 0.01 or 0.5. So this industry cannot just come by itself. It is interlinked. So this is the heart of the electronics. This is where the chip gets made, and it's diced and cut into small pieces. Then those small pieces are packaged in plastic and copper plated strips. That's where you get your connections to go to the PC board, and from the PC board to whatever system. It is I'd just like you to see this. The semiconductor wafer fab is a complex core industry at the heart of multiple businesses. So, the challenge before you today is you have an opportunity to work in this sector. For 3 decades, India has failed, spectacularly failed for multiple reasons. Now that Mysore is coming into the picture, and me being also Mysorean at heart, if you will, I don't want this to happen here again. One of the reasons we respect and admire ISRO. I did have a chance to speak to one of the project directors of ISRO. Just a few months back, I was here on a visit in May. And I was told one of the different reasons why ISRO is so successful is that they analyze all the failures before opening up a new project. They analyze all the failures. There's this big spreadsheet. They go through point by point by point what are the failures that happened. So the planning committee figures out what skills are needed, what issues are there, what is facing us, and what needs to be done. So using that as a backdrop, every single person in ISRO team, from the smallest engineer to the head of ISRO, they work as a cooperative, one gigantic cooperative, single-minded venture. This is the only reason why it's successful. Each and every person's work, whether a small programmer on one section of the satellite communication SATCOM, or direction control, spin control, whatever it is on the satellite, from that person's work to the director's work to the program director's work, each is very critical. And we have seen some of the results of the failure. One of the recent most viewed satellites to land on the back of the moon, it crashed because they had not programmed the speed of the descent at the last minute. So it was called a programming error, but I personally don't know. But whatever it is, and what I'm trying to highlight is, it is so critical that you know what you're doing. I'll come to the next one. The wafer fabrication industry, just to give you a high level bird's view. Chip design, VLSI and component design, a lot of you are doing that. India is very well known in that. A lot of foreign companies are here doing that. They have set up a shop in Bangalore, Pune, Mumbai, you got a lot of companies. It's like only one half of the coin. We are completely missing the other half. The other half is basic chip fabrication. It's the core manufacturing sector. The other picture I showed you on the top is a sample wafer. So from that, after it's cut into small pieces, little squares, which is called dice chips. Then you come to packaging. So that's where you put the copper plate and beads and plastic and package it up. So that is an entire industry sector. That alone is a $1 billion industry. And for those who are aware, if you have read your news about the Tata Group, they are already announced a $9 billion project in Tamil Nadu. But that's only half the picture. That is only for the wafer fab, just that portion. What you see is these discs. I have some sample I will show you. I will take it out afterward. You can see it afterward. So packaging itself is another industry, and why I'm mentioning that, this is a more accessible industry for India because it costs far less. all the machine shops, plating shops, EC machining, electronic chemical machining, these kind of industries are already there in India. This application works very well, where you can make these you can use in packaging. Now, subsequent to that is testing. This also is it's a multi-billion-dollar industry. It's so vast, it's so deep. So these two is where downstream I think India should start. There are a few, it's few and far in between. So at the end of this, from the fab to packaging to testing, the final end result is all a whole array of chips. So this will give you a bit of a perspective. How deep the subject, it's literally an ocean. You think of each of these sectors as an ocean there. The knowledge is so deep, so vast. You have to learn chemical electronics, the impact of chemicals, whether gold is better, titanium is better, or aluminum is better. Need to figure out which will handle more current in microamps, milliamps, nano. So all these interactive issues will come up when you're designing your VLSI chips. For what application, what current level, how is safe. So that just to give you a high level bird's eye view of the complexity. So the basic, let's go to the basic of this wafer fab. By the way, I am actually physically contributing to operating a wafer fab right now. So every day we monitor half a dozen instruments, we read half a dozen instruments, we get half a dozen reports. One of the reports, by law, by government law, we have to log it and give it to the city. And the city has the power to come and shut it down if we break the law. And where this is important, I'll mention, because we monitor the water. So we have to give a water report every day. So at the end of the month, the inspector spots anything wrong or any trouble, or we have to explain why it is so. And if you don't give a satisfactory explanation, see that water going out of the sewers or whatever, the wastewater, if it goes into the city water system, and if it pollutes and poisons, now hundreds of people, thousands of people may be affected, right? So the city should, and mandatorily does have that kind of power. So just to tell you the importance. So the basic fact, we start from the right from top. The basic infrastructure is 24/7 energy with backup, a clean room, huge amount of water and plant capacity. That's dependent on your plant capacity, how much water you use. I think India failed right in the first step itself. Forget the second, third, fourth step. Right in the first step itself it failed. I'm going back 20 years. You make all these fancy announcements, you're putting 10,000 crores, 2,000 crores, blah, blah, blah. Then a famous, I won't get into the names, but a famous American company offered $1 billion on the table to Manmohan Singh and said, we'll come and set up the plant if you give us the place, which they did. But that was the end of it. Nothing happened after that. Why? There was no power. They wanted like 1 megawatt power or half megawatt power. So there was no power there in the first place. Then they wanted water. There's not enough water. So it's just talking, for political purposes. I'm afraid this industry, you cannot deal with politics. You'll not survive. Absolutely will not survive. Strictly by merit. Strictly by merit. If ISRO is a standard bearer for India's legacy, it is by merit. Same applies here, and more so. No matter where you are, what you're doing, if the politician and bureaucrat put their hand in this management, that's the end of the show. Because 2 plus 2 is always 4, whether you like it or not. Here in this case, I'll extend it. 2.408 is 2.444408, whatever, is exactly the same, So you go to the 6 decimal, 8 decimal. That is where you need to understand the level of attention you have to pay and attend to the subject. And this is where Japan, China, Taiwan, Singapore, Vietnam, hands down, they are defeating India. Hands down. just don't even, we are not even in the race. We are not even in the race. Why? The attention that is required. 9 to 5, you're focused 100% on the job. If you cannot, you're not fit for the job. It's not that I like it or you like it, that's the nature of the business, and I'll explain why. So this is the first level. Second one is critical operating maintenance needs. This is deionized water, liquid nitrogen, clean room status, pure compressed air, oxygen. This is what I'm monitoring on a daily basis, even today. Then we have critical pure high quality chemicals that affect these deionized water, liquid nitrogen, etc. So we need a supply of pure chemicals. If there are contaminated chemicals of certain value, then your chip does not work, the electrical signals will not work. If you wanted 2 milliamps, it will give 8 milliamps. If you wanted 8 milliamps, it will give 1 milliamp. And then you'll be wondering what happened. So you should know your physics and chemistry. So basic physics and chemistry is so critical, along with chemical engineering. Then you need all these supplies. Okay, oops. I'm just taking one single example of the vast number of equipment and instruments. I'm taking only one single example to highlight because the subject is too vast. So the way these wafers are handled is they are put on a small tray and vertically aligned, and that's how they're vertically aligned. This is the end sectional view. So the furnace, there are 3 levels: temperature 1, temperature 2, temperature 3. And this is based on whatever chemistry you're doing, whatever product you're doing. Don't make sense right now, but it will once you understand, just like you pay attention to your VLSI design. For fabrication of a chip, how much level of material is required, what is the coating thickness required, how long it has to be annealed. Once you coat it, it will be raw. It has to be annealed to become strong and firm. So that's what happens in these chambers. So it's a generic, I just made a sketch just to show you. Notice that there are 5 wafers in one single tray. It's not 5 single chips. If you see this top corner there, you probably have about 10,000 to 20,000 to maybe 50,000 chips in one single wafer. So if you have 5 wafers at 50,000 each, you're talking of 250,000 wafers, 250,000 chips, sorry. If by accident you put the wrong amount of chemical, or you put the wrong temperature, or wrong gas, you destroyed one lot. What is the price of that one lot? That price of that one lot can be 1 to 2 crores. Your factory will be wiped out in no time. That is why the attention is so critical. This is why India has never been able to do this so far. Never. Except few government operation units are working, yes, I agree. Where they can afford to work at 10% efficiency, you lose 90%, they don't care. Commercial establishments cannot survive at that level. So that's why I'm trying to explain and give you an insight how much attention you need to pay to work in this industry. So I just give you one example of one process. Repeat the same on other processes: cleaning, coating, and all the complex chemicals coming in. In a way, it's like you're running a spaceship in empty space. You don't know where the meteor will come and hit you from which side. So which part of the spaceship will get damaged or destroyed, you never know. The unknowns are like that. So just to give you a sense of challenge. So batch processing, that picture I showed you was for batch processing. So in this industry, we work on batch processing. Cost per wafer, cost per batch of 5 processes, cost per lot, huge cost impact if it's lost or damaged, and average single finished wafer may contain 10,000 to 100,000 pieces depending on the geometry. I'll just show one after. Average cost of single finished wafer may be lakhs of rupees. Hence, average cost per lot of 5 wafers can be half crore, 1 crore, even 2 crores. Operating cost in a clean environment is high. Loss of clean room level significantly impacts and increases yield loss to lakhs of rupees. So what I'm referring to is we are sitting in a room like this size. This is compared to a class 10 or class 100 clean room, we have maybe 100,000 dust particles in a single cube of air. That's how you measure it. 1 feet by 1 feet by 1 feet. Inside an operating clean room, there are different levels. Class 1000 clean room, it is you got to go through a double plastic wall room, and inside it is purified air, and they've got air coming in from the top. This is also purified filter, and it will exhaust out. So that is like you can have you are allowed up to 1000 pieces of dust in one cubic foot. If all the machinery and furnaces are all operating inside clean rooms. If the clean room, if the air goes down, if the current goes off, your air shuts down, I'm not joking, you may even die. Because you are dealing with complex chemicals that may emanate, ooze out from there. So you must have backup power. You can't just shut down the current just like that. So people can get trapped inside the clean room. And we are wearing bunny suits. I wear them often when I go inside. I have to, I don't have a choice. Full length bunny suit, that is like you see in these movies, some of you now. So anyway, that is... so, okay, 1 minute, we'll stop. Okay, we'll stop here, okay. Okay, so now this is an interesting topic. This is entrepreneurship. Today this is empty blank. There is no, the field is itself empty. It's up to you to read. One of the great advantages India has throughout the world, just like me, there are a lot of engineers working in every single country, in the chip business also. So through some links, if you want, if you're serious, you can do some homework, get some good, maybe get an idea to do some chemical supply or plating or whatever. So you do have an opportunity. If you can partner with some small company and do something, you can set up a small tools as packaging and test. That's one opportunity. So mid-scale companies, $5 to $10, $15 million for packaging and test equipment, and of course for large, this is over 50 million and higher is these wafer fabs. You may see there is a discrepancy with what I'm talking here, because out of Karnataka government is talking about 27,000 crores, $9 billion, and I'm talking 50 million. This, I see that. What happens is here is you're looking at the high end. You're looking at the Cadillac car versus the basic simple, Chevy car in American language. Just the basic commute car versus the Cadillac. So in a similar sense, the wafers that they are talking about is like 12-inch wafers with probably 500,000 chips in a single wafer. So that's why the cost is so high. And everybody doesn't need that. So that's another mistake that people talk about and get a wrong impression. Yes, we need the expensive wafer fab, but that we don't need at the high level. You got a wide spectrum. Take the low end, small chips at lower level, which has a bigger geometry. And if you want to walk through, I'll keep two wafers here. You can just see these are small ones. Uh, other than that, so there is another. This is a completely blank side. Even I was going to repeat the same thing to the Chamber of Commerce and business leaders. Running a small scale industry or medium scale industry is a high risk, particularly when you're talking of, this is not like a 5,000 rupee job or 10,000 rupee job that you can manage if something fails. One failure is 1 crore. You cannot think of that. So there is a huge risk, financial implications in batch method relating to wafer fab industry. There is a huge risk if equipment or process fails. There is a sudden loss in crores of rupees. The teamwork required that a high degree of mutual trust and support, especially in a pure wafer fab. You know, like the military commando teams, their lives are at stake, literally, right? One small move, one of them may die, and they're supposed to protect each other. I give you this analogy, why? Because cumulatively, even a small fab or a big fab, you got to cooperate with each other very tightly and support each other very well. If you want to fight and destroy, you will destroy your own job, because the whole thing will come down, not just you. All the people, think of it like you're a critical link, chain link. Suppose there are 50 people working in your company, you one person, you can destroy the whole company. The potential is there. So you need to realize that. And the business owners, I'm going to explain the same thing to them. You got to trust your employees and take care of them. Because if you don't, you'll be finished one fine morning. You may be having $1 million profit one day, next day you'll be having $2 million loss. That is the staggering risk that faces, that this industry is unique to this industry. There's no other industry it's like that. So the nature of industry demands an intense focus on the job and 24/7. I'm surprised, of course, pleasantly surprised that because America is a place where you have people from all different countries. I've seen people from China, Vietnam, Japan, exceptional focus on their job, exceptional focus. Compared to generally, I mean, this has been the pattern, and I'm not putting India down. What I'm trying to say is this is the history, learn from it. Learn from the mistakes and realize what is going on. If you are going to succeed, we have to cooperate. This industry won't exist today or even 10 years from now. Believe me, it will not exist. If we can't cooperate and work with each other, it will not exist. You may have the most brilliant people, most brilliant champions. End of the day, it's like you're running a restaurant. Every day you have to have good food. Like, no, last week we had good food. Today I can put 10 amount of salt. So nobody will bother. It doesn't work like that. So even profitable firm can be wiped out overnight with defective manufacturing, as batch lot size and costs are massive related to other industries. So it demands utmost attention to quality. In fact, I would encourage, if any of you get a chance to study quality, that Deming's charts, statistical quality control, 3 sigma, 6 sigma, this is very important, because this will give you a scale of what is the degree of complexity of the quality. Not superficial quality, deep quality. If you're counting 1,000 pieces, all 1,000 pieces have to be accurate. I can't have 10 bad and 990 good. That also, there is a yield loss of 10. So that is the expectation in the chip industry. You got to have 99% almost quality. End product, when I say quality, end product, if you start 100 pieces, 99 must be finishing good shippable product. So there is a whole different level of quality also that you need to understand. So, lastly, I mentioned about the water. Okay, demands utmost attention to quality. yields drop fast with contaminated material processes. I'll give an example of my own experience in, these disks in your computers, like you have a 3-inch discs, already now you've gone into hard drive, what do you call, solid state memory. But the earlier generation disk drives, we used to have these 5-inch disk drives, and the disk drives, the surface is highly super polished the iron oxide. And on top of the iron oxide, you have a very fine chemical like an oil coating. The reason for that is when the plate is flying at a very high speed, the sensor that drops and picks up the signals, positive, negative, no. That disc, if the material, if the plate is not proper, if it's not polished, if it's not level, then the electrode that touches it will scratch it. So this company where I was working like 20 years back, they had a serious problem. They had a massive 20% yield loss. That can kill the company. 20% yield loss is unheard of. I mean, they can afford 3-4%, 5% maybe, but 20-25% is just shut the shop and go home. They're not making anything. So the challenge I had at that time was why are we losing so much in this disc process? So I spent days at each step along the production line, and I targeted one where I heard a noise. This machine takes a ceramic like a disc and it rubs the aluminum oxide and makes it flat. So the process itself is like a series of small circular discs, it's polishing. But after one disc is finished, it will go to the next, it will index. So when it indexes, it is sitting on a base that is vibrating. So every time it indexes, I could hear a vibration. And I spotted that just by listening to the sound, I spotted it. And then to prove what I had to prove, I got the company to give me a high-speed camera and focused it, and as the operations were going on, I could show them that the polishing is good, but when it jumps to the next level and again the next level, every step it shakes. So it is sitting in one place, but when it comes to the next place, it is shifted by 0.5 millimeter or 1 millimeter. It's already moved. So everywhere it's going. So this is a very important thing. It's a vibration. We needed special vibration mount pads for that machine, which they never thought about. But that is one example. But that's why quality is so critical. And lastly, this is where I said the industrial safety regulations are vital to protect staff. I already told you about water. The city comes and inspects the water. They have full authority to come at 10 o'clock in the morning or 6 o'clock in the evening or 2 o'clock in the morning. If you are polluting the water at night, if they catch you, not only will they shut the factory, you have to go to jail for 2 years. You'll spend the next 2 years in jail. That's serious. That's strict because you're affecting lives of somebody out there. If that poisoned water goes and kills somebody, they will put a lawsuit on your company, right? So they will blame the city. In the US, the rules is, okay, city, you didn't do your job, 10 people died here, so we are suing the city, we are suing you, you give $100 million compensation to our people who died here. So I'm just giving an example. So these laws don't exist here. We need to create it. So this is a very wide, vast ecosystem. I'm talking maybe 5 years into the future, but I just wanted to give you a glimpse, like a bird's eye view of this industry. So I have trouble with it. Okay, so I just want to conclude a couple of things. Karnataka is a pioneer in the energy sector on an India basis, and late Sir MB had an identical challenging environment like today. And I've read some of his books. I've had the privilege of visiting his place, and I greatly admire and think of him as a mentor. He was known for his absolute straight integrity. Nobody could change his opinion if he wanted to do something, and if somebody wanted to correct or change it. So You have your own example right there. And the analogy to the energy sector, the core semiconductor segment can create many high-paying jobs and an international presence if successful. This is the beauty of this industry. You make good chips, guess what? You'll have somebody from Australia jumping up and down and saying, I will pay you 10 rupees more, please give it to me. And you'll find another guy from Vietnam coming, I'll pay you 20 rupees more, please give it to me. Or you may find somebody from China, believe it or not, I'm not kidding. Even a Chinese guy will come and say, I'll pay 100 rupees more, please give it to me. So that is the opportunity that you have. Few people have that. Okay. So this is a challenge to your current students, future leaders. If you want to do this in Make in India. Now, there's one interesting thing the government has already done. It's called PLI, Production Linked Incentive. This is very unique. I think no country in the world has done this. So if you produce 100 pieces, good, okay, you get a certain benefit. If you produce 1,000 pieces, that's 10 times that volume. The government gives us a little bit more subsidy. So no country has thought of this plan, but it is working, believe me. It has got a great opportunity. So new industry rules and regulations related to the semiconductor industry need to be developed. There are massive opportunities in small wafer fabs dedicated to groups of products and applications, from LEDs to low-level chips for different applications, temperature control, timing control. You need low-level chips, and those can be made in small wafer fabs. So that's the opportunity there. And also there is a risk of massive failure if you don't pay attention to basics. And fundamental high-level focus on quality and reliability is the basis of success. With that, I conclude, and questions over to you. Any questions? ಬರೀ ಇಂಗ್ಲಿಷಲ್ಲಿ ಮಾತಾಡ್ತಿದ್ದೆ, ನಾನು ಕನ್ನಡದವನು. ಯಾರ್ಯಾರು ಕನ್ನಡ ಬರುತ್ತೋ ಬೇಕಾದ್ರೆ ಹೇಳಿ. ನಾನು ಮೈಸೂರಿನವರು. But I thought I may offend some people if I keep speaking only in Kannada.
Thank you so much, sir, for enlightening us with your knowledge. Indeed, it was very informative session. Now I would call Ms. Uzmatas from 3rd year EC department to render a word of thanks.
Yeah.
Good evening to one and all gathered here. On this wonderful evening, I would like to present the vote of thanks. We take this golden opportunity to thank respected resource person Mr. Shrikant Selin for his sharing his knowledge and experience in the field of semiconductors. Thank you, sir. Also, we would like to thank Dr. Saraj L, Principal of ATMEC, for his valuable advice and support. We would like to thank Dr. Bhagyashri SR, Dean Research of ATMEC. Thank you, ma'am. Also, I would like to thank all the deans, HODs and staff of the college. Last but not the least, I thank all the students for eagerly attending this talk. Without you, the event would not be a success. And event coordinators, I would like to thank event coordinators Professor Chetana and Chandrasekhar for their valuable time. Once again, thank you everyone present here. Thank you.
Thank you. Yeah.
Thank you, Uzma. As we come to end of this wonderful session, I would like to thank all our viewers and audience for their valuable time. Thanks to all the hardworking team members and making it grand success. I would like to conclude this event by the quote, technology is not just a tool. It can give learners a voice that they have may not had before. Thank you.